Okay, we're doing lesson 4.5. This is your virtual lesson for the day while we give the ACT to the juniors. But this first video, we're going to demonstrate how when we fix the length of one leg in a right triangle and let the length of another leg or another side vary, how that affects the relationship of the acute angles inside the triangle. So in this case, we'll be writing an angle as a function of one leg of the triangle while the other leg is fixed. So let me bring that here. Let's make this the leg that's going to vary. And let's let y be the angle, one of the acute angles inside a triangle. So let's think about what's the smallest that x can be. If we let x get smaller and smaller and smaller while we fix that other leg at 3 units, then the smallest we can get with what we know so far is that that side length x has to be bigger than 0. So the domain of this function is going to be bigger than 0. We're going to write y as a function of x. So we're going to have an equation that says y equals some expression with x. Now, if we look at this, I'm going to get it on the cut, give us one we can draw on. If we look at the relationship with y, we know that the tangent of y equals 3 over x. That's the opposite side over the adjacent side. What I want to do is solve this equation for y. So I'm going to take the tangent inverse to both sides. And when I take the tangent inverse of the left side, it's going to cancel that tangent. And tangent inverse of the right side. And so I end up with these cancel, and I end up with y equals tangent inverse of 3 over x. And recall that an inverse trig function gives you an angle. So what we watch what happens here in our triangle, this is the function that I would be writing to get y as a function of x, get the angle y as a function of x. So we think about this, as x gets smaller, and that angle y stays at this little corner, that angle is getting larger and larger and larger, getting closer and closer and closer to 90. As x gets larger, now x can go to infinity, because we can continue to make x larger and larger and larger, but the angle y is getting smaller. So when we look at this, the domain of this function, if we're constricted to this right triangle, x can't be 0 or negative, so x has to be bigger than 0, but x can go to infinity. That's the domain of this function. And the range of this function, y, the y value is the angle, and we look back here, and that angle y, remember, as x gets larger and larger and larger, this y gets smaller and smaller and smaller. And if we could picture taking this x out to infinity, then y would get closer and closer and closer to 0. As we make x smaller and smaller and smaller, then the y value gets closer and closer to 90, but can never reach 90, or we won't have a triangle. When it reaches 90, then we don't have a triangle any longer. So the range of this function that we just came up with is also 0 to, 90, not 0 to infinity. But it can't reach 90. And that's how we write a function in terms of x for the angles y inside a triangle. If we were going to do this one, let's call this one z, and let's write z as a function of x, then we could say that tangent z equals x over 3. And if we take the inverse tangent of both sides, we take the inverse tangent of the left side, we get z, and z would equal the inverse tangent, or the arc tangent, remember we can write that like that also, of x over 3. And so when you're dealing with a triangle and you're looking to find a function that gives you the angle inside a triangle, you write a trig relationship. And if we wanted to find the hypotenuse, let's say that, no, we'll do that on the next video. This is for finding the angles. So this is how we write a function, finding the angles of the triangle when we let one leg vary and we fix another leg.